time, our forefathers have been making use of such. And now, because of the cost implication of the orthodox, many people are equally taking recourse to it these days. However, recent advancements in both life and physical sciences, coupled with analytical methods, have unlocked new potentials and applications for phytoceuticals and nutraceuticals, making them very relevant in modern healthcare. Like I said, for the bioactive compounds, which are the heart of the phytoceuticals and nutraceuticals, we are told, of course, they contain the is it 2 o'clock yet? It's 3 o'clock. The Futarians, we appreciate what the story is. Unfortunately, I have my iPad. In the vehicle, and are we? Yeah. Yes. Sorry. The bag. You see in the iPad in the boot. Yeah. I don't know. Are we waiting for? Is there any hope for? Huh? Okay. So, we want to have a quick rundown of the bioactive compounds. Bioactive compounds. And these include, of course, we have the flavonoids, having the general structure as presented on the board. The flavonoids are generally found in fruits, vegetables, and of course tears. They have antioxidants and anti-inflammatory properties. The alkaloids. The alkaloids are present in plants like peppers and coffee, and they have diverse pharmacological effects. Of course, one of such is the agot alkaloid, which structure we have right projected there. Then we have the polyphenols. The polyphenols are very much abundant in fruits, like grapes and berries, and they are known for their cardioprotective and anti-cancer properties. And of course, we have the terpenoids. The terpenoids are found in essential oils and herbs and have antimicrobial and anti-inflammatory effects. What I've done in the on the topic is to take a record to our own research activities just to convey the message. So what I've done here is just to pick on few of our research outputs by way of publications to draw our attention to the use and the activities, of course, of a number of phytoconstituents, the phytochemicals, which are derivable from plants. Here, of course, this is a this is a work essentially on this COVID-19. And for this one, of course, we have a herb that has some activity against the COVID-19. You know, at least even at that point in time, that the issue of developing vaccine and things like that are not things that come handy readily or things like that. So, again, there have been recourse to a number of pharmaceuticals, pharmaceuticals to combat the COVID-19. Of course, this one is on one of the neurodegenerative diseases that's on Parkinsonism, whereby we have dihydroquercetin, which improves erythroid-induced Parkinsonism by, of course, these inflammatory pathway which we have. Again, this is an area of the mental health, depression, where, of course, there is recourse to these plant material to combat what you have there. Again, still on quercetin, the use of quercetin and things like that. The highlights of that include both catechin and quercetin. Of course, they both ameliorate rotenol-induced neurobehavioral deficits. They equally ameliorate the rotenol-induced striatal redox imbalance, and they equally correct the disturbances in the strata neurochemistry so induced. This refers to the proton, NMR, and HPLC that mass spec for the characterization of the number of phytoconstituents that we have in the plant so investigated. Again, essentially here, a number of phytoconstituents were discovered for the first time as far as this characterization is concerned. And again, we have these ginger and turmeric rhizomes, where we have this one, and the highlights include the two of them, both turmeric and ginger rhizomes, decrease ATP and AMP hydrolysis, and of course the decreased ADA activity and that of acetylcholine esterase activity. This is in the area of nutrition. Dietary supplementation of tiger nuts alters the biochemical parameters relevant to erectile dysfunction. Again, the highlights here talks about a reduction of the activities of adenosine deaminase, acetylcholine esterase, and arginase. This is another one which is very much on the flavonoid that we have on this Alzheimer's disease, again, on one of the neurodegenerative diseases. The phenolics composition, again, we have this one, which of course refers to these alpha amylase, alpha glucosidase in respect of the diabetes type 2. This has to do with the antioxidant activity of one of the plant materials. And of course, again, characterization of the phytoconstituents. For the various research outputs from our group that are so projected, I have a kind of summary that I put up here. And the summary includes, of course, the activities. Essentially, a number of the therapeutic activities revolve around all these mechanisms that we're talking about. We have antioxidant activities, neutralizing free radicals to prevent cellular damage, anti-inflammatory effects, which is modulating inflammatory pathways to reduce chronic inflammation, and of course the immune system support, which is enhancing immune responses to protect against infections and disease. And of course, we have the gene expression modulation, influencing gene expression to promote health and prevent disease. A few of the advances and innovations, which is part of which was covered in the keynote address. Genomics and metabolomics. The integration of genomics and metabolomics has allowed for the identification of novel bioactive compounds and understanding their mechanisms at a molecular level, which many times is at the heart of biochemistry. This helps in designing targeted nutraceuticals and phytoceuticals with specific health benefits. In the area of nanotechnology is being utilized to improve the bioavailability and efficacy of phytoceuticals and nutraceuticals. Nano encapsulation protects sensitive compounds from degradation and enhances their absorption in the body. Many times for a number of the drug formulation, those are challenges where you are talking about bioavailability and at times even the stability because of biotransformation before getting to the target site. This technology readily comes handy. And we have the personalized nutrition, whereby we have advancements in personalized nutrition, which are tailored phytoceutical and nutraceutical interventions based on individual genetic makeup, lifestyle, and health status. This approach aims to maximize health benefits and minimize adverse effects. A number of times these days, in some cases, one because of maybe the underlying pathology suffered by some individuals, or in some cases whereby we are having some genetic related diseases. These are some of the tailor-made approaches to such healthcare delivery. And we have the chronic disease management. The pharmaceuticals are increasingly used in managing chronic diseases such as the cardiovascular disease, whereby we have polyphenols and omega-3 fatty acids, help reduce the risk of heart disease, diabetes. Compounds like heparin and curcumin improve glucose metabolism and insulin sensitivity. And of course, for cancer, various pharmaceuticals exhibit anti-cancer properties, potentially reducing the risk and progression of certain cancers. In the area of mental health, nutraceuticals like omega-3 fatty acids, B vitamins, and certain amino acids support brain health and can help manage conditions such as depression, anxiety, and cognitive decline. And for gut health, probiotics and prebiotics types of pharmaceuticals play a crucial role in maintaining gut health, influencing digestion, immunity, and overall well-being. And like we've been told earlier on, again, that's an area touched even in the keynote address too, in the area of the regulatory challenges that this approach of healthcare delivery system faces. In the area of quality control, ensuring the quality and consistency of pharmaceuticals and nutraceuticals remain a significant challenge. Of course, standardized extraction processes, proper labeling, and rigorous testing are essential to maintain product integrity. If you remember, I told us earlier on that, of course, the use of plants or whatever dates back thousands of years. And in the past, our forefathers making use of this concoction, agbo, and things like that. Many times, the issue of dosage, the issue of any form of purification or whatever has always been a problem. And so, in the application of science, it's impossible to address some of these things. It's impossible to address some of these challenges, but of course, we are not yet where it should be. More so when it comes to the question of the orthodox person, and some of these things suddenly come facing this delivery. And so, I have these conclusions to make. One, the frontier of phytoceutical and nutraceutical research holds immense potentials for revolutionizing nutrition and healthcare. By harnessing the power of nature, which we have in the plants, and integrating it with cutting-edge science, we can pave the way for healthier lives and more effective disease prevention and management. With advances in science and technology, the impact of these natural compounds on our health and well-being can only grow. And lastly, phytoceuticals and nutraceuticals are exciting and rapidly evolving fields. These natural compounds are at the forefront of a revolution in nutrition and healthcare, promising innovative solutions to many of the health challenges we face today. Thank you.
Thank you very much. I think we can still sustain that clapping to appreciate our professor for the lecture he has given. Summarily, he called our attention to the fact that we have phytoceuticals and nutraceuticals. They are not the same, but both are from plants. You know, food are from plants. The one from plants will give you therapeutic potentials only. The nutraceuticals will give you both health benefits as well as nutritional benefits. And we have so many of the compounds present in both responsible for the health benefits they produce. We have alkaloids, we have flavonoids, we have terpenes, we have polyphenols, and so on and so forth. And according to our lecturer, some of these bioactive compounds are responsible for the therapeutic potentials reported. He gave us arrays of publications from his group and what that publications has offered. He also gave us summary that both of them, either nutraceutical or phytoceuticals, that they have some common potentials in them responsible for the activities they represent. For instance, some of them are antioxidants, anti-inflammatory, and so on and so forth. And he also mentioned that we have advances in genomics and metabolism that has given explanation to the use of these compounds. So also nanotechnology has made it easier to improve the bioavailability and the efficacy of these compounds. So also he made mention that some of these compounds, either from phytoceuticals or nutraceuticals, they are available to take care of chronic diseases such as cardiovascular diseases, diabetes mellitus, cancer, and so on and so forth. And from the presentation and from the publications he displayed, we can see that we have arrays of chemicals in different natural products that can address this problem. Then there is one setback that he made mention of, that is regulatory challenges. That is, we are still finding it difficult to do quality control of some of these products. You have some of them available as polyherbal drugs in the society with NAFDAC number, but I'm not too sure whether they are properly controlled. So we have listened to his presentation, so we entertain 3 questions from him. From you to him, sorry. 3 questions on the topic. Maybe you have something you are not too sure of. Just 3 questions because we have another person coming up. So we take the questions. Who is number 1? Number 1? Only one person? Only one? After the number 1, nobody is asked. Okay, number 2? Who is the 3rd person? So we have 2 questions. Number 1.
Thank you, sir, for the presentation. My name is Dr. Ularafe from Nigeria Police Academy, Kano. My question is in regard of the extraction process and the characterization. Most of the time when we carry out extraction, how do we actually point at which of the phytochemicals to be extracted? Because most of the time we have been talking about crude extract, and most of the work you have presented are actually pinpointing 1 or 2 particular phytochemicals that are responsible for this bioactivity. Thank you, sir.
The second question.
My name is Abdullah Lukman from Kwara State Polytechnic. Thanks for the wonderful presentation. My question goes thus. You mentioned the nano encapsulation earlier. I want to ask if there is any standard method that can be used, if there is any standard method that can be used to nano encapsulate some of these phytochemicals you have mentioned, or if there is anywhere we can be directed to that we can be sure of what we are actually doing. Thanks for the response in anticipation.
Thank you. Over to you, Prof.
Thank you. So we had two questions. The very first one is on extraction, and the second one is on the nanotechnology. The very first thing is, by way of extraction, by the time you do it, the very first thing is you come up with the crude preparation. All right? And what is extraction? Extraction is the use of solvents that solubilizes the active principle that you are talking about. So you have array of solvents ranging from the universal solvents, that's water, ethanol, and even the organic solvents. Is either two things. One, is either you go through some preliminary investigation by which, of course, you try different solvents and you're able to get the yield and things like that. Or you take recourse to literature. Maybe what you want to do, you have earlier works already done and things like that. You can make reference to that. And so you come up with the crude preparation. For crude preparation, whether in terms of the biological activity or even the publishability of what you have. Ordinarily, when you have the crude preparation, you can't be too sure as to the pharmacological activity, whether it is due to the active principle or to maybe the contaminant, the impurities you are talking about. And there are different methods for purification. Many of them, of course, these activity-guided purification, that you attempt some purification, check for the activity. Of course, you have your targets and things like that. And you have quite a number of biochemical techniques. You have your gel filtration, and of course, your electrophoresis. Many times, by the time you target the issue of homogeneity, you have an idea as to the level of purification. But one thing about purification is that what is pure at a certain level for certain investigation might not be pure for another level or for another investigation. So it depends on what you are targeting about. But of course, ordinarily, a number of these things, either you go through the thing empirically or you take recourse to literature, and that is it. For the second question, the nanotechnology. The nano there has to do with the quantities. You know, you go from your kilogram, gram, microgram, then nanogram. Of course, it has to do with quantity, and again, when you are talking of technique, it depends, it varies, depending on what you are talking about. Even with the drug formulation you are talking about. But the thing about it is that you are talking of the very, very minute quantities. That's in reference to whether gram, microgram, nanogram. But as regards the practical side of it, of course, it's a wide range of possibilities. Thank you.
Thank you very much. I think we can do better to appreciate him.
I want to appreciate Prof. for that beautiful contribution. You can see the extent of the work which have been done by him and his group here. And I must say that this kind of work is being duplicated all over the universities in this country. I'm saying there's the need to pull these things together. Particularly, we are using our own local materials. And look at the extent they have gone. Sometimes you now start a PhD student on the same thing. Whereas if you pull these works together, of course, you can go online and get it. But we want to say in Nigeria, we have people who have been working relentlessly in this area. We talk about diseases, they're already talking about it. What type of food are you going to take that it contains the relevant things that can assist you? So, Prof, I want to appeal to you. And I want to appeal to NISEB. This is the reason why we do this kind of a conference, to pull ideas together. And if Futa can champion it, he been on, doing quite a lot of work. And the other universities that are here present, you will discover that we are also doing something that is very relevant. Why don't we come together? By the time we come together and have a kind of a compendium, we can also build, we can say to the government, yes, we are doing something that can be respected. Thank you very much.
Thank you very much. Like Prof have said, and the other Prof has spoken, he also mentioned something called personalized nutrition. My genetic makeup makes me fat. Doesn't mean I'm eating twice your meal. And it is called, I have abnormal metabolic system. So what I would decide to place myself on as a diet will help me and will make that gene responsible for obesity not to thrive well. Thank you very much. Now I call on Professor Oloyede to help us present this plaque to the lecturer.
On behalf of NISEB, we present to Professor A.A. Akindaunsi as a resource person and for giving us this beautiful presentation, which we can also say that we are taking home. Thank you very much. Congratulations. So, wait. Congratulations.
Thank you very much. If you look at the program, we have another lecturer coming up to give us a lecture on Professor A.U. Osage, that is Professor A.U. Osage Memorial Lecture, to be delivered by Professor Spencer Nwagu. You are welcome, sir. Sir, you have 30 minutes.
Thank you very much. I am Professor Spencer Nwangu from Igbenedion University, Okada, and I bring you a warm greeting from my Vice Chancellor, Professor Lawrence Ikechukwu Ezemonye. And I'm going to be speaking on climate change and food security, relevance of experimental biology, technologies as tools for climate-smart agriculture. Thank you. As tools for climate-smart agriculture. Professor, let me also align myself on your style of presentation and go like a teacher. I want to be mentored. So, I'm going to speak on this topic, but first, I want to first Okay. Thank you. The mentorship still continues. First and foremost, I want to really appreciate the organizers of this conference, and I am humbled by this invitation to deliver the Professor Anthony Uyukben-Osage Memorial Lecture on this 23rd Annual Conference and General Meeting of the Society for Experimental Biology here in Federal University of Technology, Akure. I want to start by thanking the organizers once again for the privilege and honor accorded me to present this paper. But permit me to start this presentation by sharing with you some of the brief insights on late Professor Anthony Uyukben-Osage. This is our father, Professor Anthony Osage. Professor Anthony Osage joined the Department of Biochemistry at the University of Benin as a foundation staff in 1974. He was appointed Assistant Dean of the Faculty of Science in 1984 and head of the Department of Biochemistry in 1985. He was promoted to the position of a full professor of biochemistry in 1987 at the ripe age of 40. And by 1990, he was appointed Dean of the Faculty of Life Sciences. He was a reviewer of many scientific journals and external examiners. He supervised numerous undergraduate, master's, and doctorate degrees students, including my humble self. Unfortunately, he did not live to see me become a PhD holder in biochemistry, and it was concluded by our newest fellow, Professor Mrs. Omoroge. Help me thank her. Professor Osage served as Vice Chancellor of Igbenedion University, where I work now, in Edo State, between 1999 and 2004. He belongs to so many associations. He was a fellow and the past president of the Nigerian Society for Biochemistry and Molecular Biology, fellow chairman, board of trustees of the Nigerian Society of Experimental Biology, member, Nutrition Society of Nigeria, member, Science Association of Nigeria, member, West African Science Association, member, International Union of Biochemistry and Molecular Biology. Professor A.U. Osage authored over 100 papers and reviewed articles on plant lipid composition, microbial chemistry, and anti-nutritional factors in food. His research interest was post-harvest science, biochemical changes associated with chronic malnutrition, and plant biochemistry. He was interested in plant lipid as food store and important commercial sources of fat and oil. He worked on the increasing the production and utilization of conventional oil sources through understanding the biochemistry of lipid synthesis in palm oil. Professor A.U. Osage was interested in food. Professor A.U. Osage was interested in food security. He was interested in nutrition. He also worked on crude oil extract from underexploited seeds and determining the suitability of oil for edible and industrial processes. Tropical post-harvest research, where he took critical look at yam tuber in storage. The use of molecular biology techniques to extract, purify some carbohydrate degrading enzymes in yam tubers, as well as isolation and analysis of yam DNA and RNA. He worked on the use of genetic engineering techniques to improve the storage properties of yam tubers via introduction of desirable gene or set of genes into the genome of the target plant. Without doubt, it is obvious that Professor Sage was working towards food security and means to achieving food security. Therefore, I was constrained to look at this topic, climate change, food security, relevance of experimental biology technologies as tools for climate smart agriculture. The impact of climate change is real, though some still doubt it, as it affects crop yield, soil health, and water sources and livestock. The United Nations World Food Programme reported that over 800 million people lack food to support a healthy and active life. The attainment of zero hunger, that's the SDG 2, through food security under the dimensions of food availability, food accessibility, food utilization, and food affordability may not be achievable because of the impact of climate change as a primary driver to acute food insecurity. This is the common sights we see now. Flooding of farms, down south here, drought in the northern areas. This presentation is intended to stimulate interest in food security, is intended to stimulate interest in food security from the perspective of experimental biology. The climate smart agriculture provides means for adapting to changing climate by maximizing the benefits and minimizing the adverse effects. Alleviation of food security requires closing yield gap, increasing production limits, and reducing food waste. This can be enhanced by experimental biology technologies as tools for climate smart agriculture. For that reason, there is urgent need for sustainable solutions. We're looking at urgent need for sustainable solutions, but we have to have an overview of what climate change is and how climate change can affect agriculture. United Nations, the UN defined climate change as a long-term alterations in temperature, weather patterns that is attributed to natural processes resulting from changes in the sun activities or large volcanic eruptions. However, since the 1800s, human activities have been the main driver of climate change, primarily due to burning of fossil fuels like coal, oil, gas, and generation of greenhouse gases. Greenhouse gases are gases in the Earth's atmosphere that trap heat, thus contributing to the greenhouse effect, resulting in the warming of the Earth. And the greenhouse gases include carbon dioxide, methane, nitrous oxides, fluorochlorocarbon, and hydrofluorocarbons. These are some of the first. Switch on to any news channel, you are talking of wildfires. There is one in Portugal now. You are talking of melting of the ice cape. What does this result to? Flooding. Streets turning into rivers where you use canoes. Villages and towns looking at swamps where you have small vegetations. Farmlands turning dry as a result of drought, making it impossible to farm. How does this impact agriculture? We'll consider the impact on agriculture on 4 primary interrelated mechanisms, one of which is rising temperature. Rising temperature plays a significant role in agricultural crop development and preservation. Frequent changes in extreme weather events, which results in drought and flooding. Varied distribution of arable land. This is critical. because climate change is projected to increase the availability of arable farmlands in high altitude regions like the northeastern Europe and Russia. While equatorial regions, which is sub-Saharan and Brazil, will experience reduced arable land. This is simply because as the ice cap melts, water levels rise, and it is predicted that it's going to get up to 7 meters. If that happens, that means most coastal areas will now become water, and it will be inhabitable, not to talk of farming. We also talk of increased carbon dioxide within the atmosphere. This has both positive and negative significance on plant functions and development. If climate change affects agriculture, how is it related to food security? But first, we'll try to understand what food security is. According to Dasgupta and Robinson in 2022, it defined food security as when all people at all times have physical and economic access to significant, safe, and nutritious food that meet their dietary need and food preference for an active and healthy life. The Global Hunger Index said that the gains of Sustainable Development Goal 2, which is zero hunger, has been stalled by war in Ukraine, and in red, climate change and related events. Still climate change underlined again. But let us view food security or food insecurity by under these dimensions. Physical availability, where we talk of production, supply, and stock level of food. Economic and physical access of food. In this dimension, we look at how food gets to the house. And it reminds me of, I think recently they announced that you can get a bag of rice for 40,000. I don't know how many homes have been able to buy a bag of rice for that 40,000, because that's exactly what economic and physical access to food is talking about. Then we look at food utilization, and we now look at the stability of all the three factors. What is the current global status of food security? The Food and Agriculture Organization of Nigeria. Africa has the largest percentage of population facing hunger when compared to Asia, Latin America, Caribbean, and Oceania. Africa accounts for 298.4 million people of the over 800 million people that have faced hunger in 2023, compared to the 41 million that we have in Latin America and Caribbean, and 3.3 million that we have in the Oceania. If we look at this table shows the prevalence of food insecurity, severe levels only, and moderate or severe levels based on the food insecurity index by the Food and Agricultural Organization of Nigeria. If you look at the prevalence, severe, let's go straight to 2003 for want of time. The world rate is 10.7%. Africa is 21.6%. If we break down Africa at 21.6%, North Africa is 11 points, Sub-Saharan Africa is 23.8. That's where we belong. If we come down further, East Africa 24, Middle Africa 38, and West Africa is about 18. We fall among the category of people that are endangered because of food security. If we do a comparison of globally, we see that Africa ranks very high. If I pick the prevalence of moderate and severe food security, based on that, we have 28.9 as per the world. Africa is at 58.1. The gap is massive, and we need to begin to do something. The 2024 revision of the world population by United Nations is giving a figure that is alarming, because if you're talking of food security, you can't isolate it from population. It still has to do with feeding a growing population or a large population, which puts the world population which puts the world population at about 8.1 billion. And this projection surpassed the initial projection in 2022 by 46.4 million people. That was the prediction in 2022. This figure reflects an ongoing growth with an annual rate of 0.9%. That's very dangerous. Central and Southern Asia had 18.1 million more than the expected growth. Africa had 16 million more than the expected growth, but a percentage of 1.33 higher than that of Asia, which is 0.85. In 2023, 1 out of every 11 people were faced with hunger issues. But in Africa, it's 1 out of 5. The increasing population comes with the challenges of feeding growing population under the climate change conditions. And one of the solutions that has been preferred in the face of climate change is what they refer to as the climate smart agriculture. What is climate smart agriculture? Climate smart agriculture was first proposed in 2010 at the Hague Conference. But the Food and Agriculture Organization defined climate smart agriculture as an approach to help the people who manage agricultural system respond effectively to climate change as an approach. The World Bank Group, from their own perspective, defined climate change from the perspective of integrated approach to manage landscape, livestock, forest, fishery, with a view to addressing the interlinked challenges of food security and climate change, linking food security and climate change. Climate change, according to Lipa et al., can also be defined as an approach for transforming and reorienting agricultural developments under the present realities of climate change. The implications of climate change agriculture is not a set of practices that can be universally applied. It is not a one-size-fits-all. Climate change relates to actions both in the farm, beyond the farm, and incorporates the technologies, policies, institutions, and investments. Climate smart agriculture stands on a tripod. 1, increasing productivity. 2, enhancing resilience. And 3, reducing emission. Here is a little demonstration saying what is climate change, what do we hope to achieve with climate change, sustainable increase in the production and income, strengthening resilience to climate change and vulnerability, reducing agricultural contribution to climate change, and in all, what do we get? National food security and the achievement of the sustainable development goals. The research direction in climate smart agriculture would include greenhouse gas mitigation in agriculture, carbon storage, impact of climate change on agricultural systems, then adaptation to agricultural production and climate change. What is the role of technology? Climate change, technologies that are available for climate smart agriculture. Precision agriculture, which has been mentioned here. Climate resilient crop varieties. Water management and technology. Soil management, agroforestry, livestock, integrated pest management, renewable energy in agriculture, post-harvest management, and digital agricultural platforms. Experimental biology is sometimes you challenge what you know. So I decided to do a quick Google search on what is experimental biology. And it came up that is a set of approaches in the field of biology concerned with the with the conduction of experiments to investigate and understand biological phenomena. I pushed it further to ChatGPT to understand further. And ChatGPT said that experimental biology is a branch of biology that involves the study of living organisms and their processes through controlled experiments. It seeks to understand the fundamental mechanisms of life by directly manipulating biological systems under specific conditions, allowing scientists to observe and measure the effect of those manipulations. Therefore, experimental biology, in the context of climate change, climate-smart agriculture, involves the use of advanced biological techniques and approaches to develop crops, livestock, and agricultural practices that is resilient to climate change. So what are the technologies that are available? Experimental biology technologies that are available. You have single-cell sequencing. We have the CRISPR and gene editing. We have the spatial transcriptomics. We have artificial intelligence and machine learning. We also have high-resolution imaging and techniques. Synthetic biology is there. And metabolomics, proteomics, and quantum biology. But I want to point out at this point, sometimes if we say GMOs, we are very quick to shout and reject it. But I don't think we are very correct. Because I remember growing up, for you to raise a full chicken, it takes you about 3 to 4 months to have a full-grown chicken. But today, 6 weeks, it is ready. And I wonder whether it is not genetically modified. I also know that in cassava farming in those days that we do it, it takes a year and more before you can have a good harvest. But today, I can tell you that within 6 months, you can harvest your cassava. And I wonder if that is not genetically modified. So, experimental biology has a link with climate change because it helps us to understand stress responses that affect plants. It helps us to discover genes and able to characterize the genes for us to be able to select plant species that we have. Metabolic engineering, which involves in the modified biochemical pathways and enhance the production of metabolites involved in stress tolerance of plants. It helps us also to monitor the antioxidant defense system in plants to help them adapt more to climate, to help them to be more climate resilient. It helps understanding of the hormonal regulations in plants, which has associated with resilience. Genome editing helps us also using the CRISPR to input or remove genes that may affect plants and help them to be more tolerant to stress. So here now we are looking at experimental biology techniques that can be used. We'll talk of genetic engineering, molecular breeding, synthetic biology, and microbiome engineering. We have to do with epigenetics. We have to engineer a plant to have memory of adverse conditions so that by the time such environmental conditions come back, the plant or organism is able to adapt better to it. We have metabolic engineering as part of it. And in practice, I wanted to give you specific examples of use of experimental biology techniques. CRISPR and this associated protein 9 is used for drought-resilient crops like rice. It is used to edit or knock out the response gene to drought stress in these organisms, thereby in rice, thereby allowing the rice plant to adapt more to drought situations. We also have transgenic crops and heat tolerance. Here, this involves the introduction of some heat shock proteins in those plants so that to allow them to overcome the stress of climate change. There is better metabolomics and stress resistant in barley, which can also be applied in barley. We can also apply it to enhance photosynthetic activities in plants. In conclusion, because I've been asked to, wind up. In conclusion, I want to say that experimental biology provides a valuable insight into the fundamental processes driving climate change and ecosystem responses, informing scientific understanding of climate resilience in plants. The understanding and monitoring of these biological responses to climate change are critical for informing conservation efforts and management strategies and policy decisions aimed at improving food security through climate-smart agriculture. Biological processes profoundly influences carbon sequestration and release of terrestrial and aquatic ecosystem. By studying these processes, scientists can better understand the mechanisms driving carbon cycles and its implication for climate change mitigation and adaptation. Photosynthesis is vital processes for carbon sequestration, playing a crucial role in mitigating climate change by removing carbon dioxide from the atmosphere and storing it in plant biomass and soil, using it with the application of climate-smart agriculture. I dare to say that the gains of climate-smart agriculture can be improved on by application of experimental biology technologies as tools to salvage Africa from the now chronic food insecurity. Sustainable food production and food security via climate-smart agriculture can be achieved when experimental biologists incorporate local farmers, what we call of traditional agricultural knowledge, to scientific quests for crop and livestock resilience to climate change to grant food security. Thank you very much for listening.
I think we can clap better. He has actually taught us a lot of things as to how climate change affects agriculture and food security. The impact on agriculture, it increases temperature, drought and flood, and varied distribution of arable lands. So also increase in the CO2. And when you talk of effect on food security, physical availability, and economic and physical access to food is affected by climate change. And he mentioned arrays of experimental biological techniques that can be used as tools for climate-smart agriculture, among which you have genome editing, genetic engineering, synthetic biology, and so on and so forth. So it's time now to take few questions from the audience. We have 3 people, number 1, number 2, number 3. Okay, we have 3. Number 1, your question.
Thank you very much. I'm JB Minari from University of Lagos. I want to congratulate the presenter, presenting on behalf of the memory of Father Professor Sagai. I think I met him once in 2004 when they hosted us in Okada for NISEB before he handed over to Professor, I think, Sagai. Thank you very much for the wonderful presentation. My question is, considering issue of the climate change, I realize that several issues, conventions have been held on climate change. And with the climate-smart agriculture, can we categorically say that we are making progress? Because considering what is happening here in Nigeria, part of the major reason why we are having issues is the herders farmers crisis, and people have postulated that climate change has played a major role in pushing the herders off their region down the middle belt. And so I keep wondering, I remember there was a convention in Dubai this year that a large contingent of Nigerians went there. Are we making progress, or is just all rhetorics about this climate change? That's my question. Thank you.
Thank you very much, the presenter. Also delighted in your presentation. But I have two things to ask. The first one was when you were giving the statistics of food insecurity in the world, that's in Africa. I was thinking you will streamline it to Nigeria in particular, because that is the focus of the presentation. And it would have been better if it was streamlined to Nigeria, so that we know the critical nature of food insecurity in Nigeria. I was expecting that, but it was just West Africa and West Africa. Number two is that this smart technology, the genome editing, proteomics, metabolomics, are they all included in the smart technology, or smart is on its own? And if smart is different from all these, what is the practicality or the relevance of it to Nigeria's situation to curbing food insecurity? Because everything we are doing should be localized to Nigeria on how to develop, because hunger is in the land.
You already answered it.
Thank you very much. I also want to add my voice to congratulate the presenter. Thank you for that insightful presentation. My question is similar to the last two. And what I say is that, are we ready for smart agriculture in Nigeria based on what you have presented? How can smallholders farmers benefit from this? Because one of the ways by which it had been postulated that we can wingle out of food insecurity that we found ourselves in the country is to encourage smallholders farming. That means everybody can find a place around them to be farmers. So can we use this technology, precision agriculture, based on the template we have highlighted for ourselves as a country? Thank you.
Over to you.
Thank you very much for the questions. I will start from the very first questions, which is asking whether I can say categorically that climate smart agriculture is working. I will remind you that the essence of my paper is sensitization to increase interest in this area. By that, it is not yet working. But I will tell you that one of my students is making it very well, which is the Upepsia place. It's in Ogun State. All he does is climate smart agriculture. He produces and he sells to the market. So it's an ongoing process, and it is the intention of this presentation that more people will show interest and make it work. Don't forget that I mentioned earlier that it is not a one-size-fits-all. It is something that you adapt to the environment where it is. And I went further to say we can even incorporate traditional knowledge. That means it will vary from one area to the other, from one culture to the other. I give you a typical example of there was a conference I went for on issues of climate change. So the professor was presenting how the white man will come with its solution, bring us his solution. They were having issue of water. So they decided to dig a well within that environment so that they don't need to go far to fetch their water. Unknown to them, that was not really what they wanted, because they observed that adults or parents use that quiet time in the morning for themselves while the children are away to go and fetch water. So what the white man has brought now is that the children will now always be available, denying them their private time. What did they do? They went and poured oil into the well. So why I'm saying it is that we adapt it. The climate smart agricultural approach for any area should be adapted to the socio-cultural nature of that particular area. And that way it is going to make it work. For the farmer header crisis, yes, you are very correct. Climate change is responsible for movement towards down south. But the further that cow can graze, if we adopt climate change agriculture, it can be produced. Eupepsia place, they can produce it, but it needs buying and policy making for it to be effective. The next question is saying, relevant food security in Nigeria. Yes, it's part of the one. In Nigeria, yes, I can say it can achieve that, because it depends on the approach. We have raised the awareness here. We have spoken on the importance of climate change agriculture and how it can improve food. We have mentioned that we can use our studies as experimental biology, the technologies we have, to try to influence the output of agricultural products. And by that, if we now apply it to our local setting, it's an ongoing thing. It is not final, please. It is something I want to stimulate interest so that we begin to look into it and know how it's going to work best, not for Nigeria, but for every region in Nigeria. Because what will work in the north may not work in the south. So, for the last question that said about whether we are ready, for now, I don't think we are ready. The idea is let the discussion continues and bring in more people into the fold so that we'll begin to develop our own indigenous patterns to climate smart agriculture. For the smallholder farmers, they can be assisted. I'll give you an example. These days, some people produce their yam in sacks, just within their environment. They avoid the headers. Within your environment, you can create precision agriculture, where you determine the amount of water, the amount of nutrients. It is sold now. You can buy those nutrients. It is sold now. You can do it within your environment. So families can also begin to feed themselves and work towards food security. Thank you very much.
Thank you very much. I think we can clap better for him. Now it is time to appreciate the lecturer. I call on Professor Yakub to help us do the presentation of... It's not around. So I will disturb my professor again. I wanted to say, let our daddy rest. So I call on Professor Oloyede to help us do the presentation.
On behalf of NISEB, I present to Professor Spencer Mwago for delivering the Professor A.U. Osage lecture. This was a very beautiful lecture delivered. And I just want to add that the people who are coming up with communique, You know that the issue that is of importance to us in this country today is about food security. NISEB wants to lend a voice to how we can go about it. It's still ongoing, but we are not going to wait. We must continue to push on. Thank you very much for that beautiful presentation.
Thank you, sir. I call on Dr. Ademosun to lead us to the next phase of the conference.
Please, can we appreciate Professor Lale and Dr. Ogumoyole for a good job. Thank you so much, ma. Thank you so much, sir. We will go straight away to the technical sessions. So please, let's take note. There will be 4 points for presentation. Group 1. Okay, you can check your book of abstracts. Your presentation already has a number. So if the number begins with FSSA, nano, or omics, you are in group 1. Group 1 will be on the left side. Downstairs, please stand. Yes, my right, but they are left. Okay. Will be on the left. Okay, your left. Downstairs. So she will be taking the slides right away. So please, FSSA, nano, and omics. So please go to her and load your slides. Group 2, if yours begins with BCB or BIOD, BCB or BIOD, that will be on the right. BCB or BIOD, that will be on the right. The chairman for group 1 is Dr. Popola. So he's there and he's ready. For group 2, Dr. O.A. Alabi. Dr. O.A. Alabi is already there. BCB, BIOD on the right side. Group 3, PMC. PMC, please, you'll have to go upstairs. You'll have to go upstairs on the left. Upstairs on the left. Please go load your slides right away. And group 4,